Hi class, this is Neil, and this is the next part of lesson 8 from unit 8. We are going to be looking now at the next example problem, which if you're following the lesson on the PDF, it's on page 4. So in this example, we're really going to be looking at using the same thing we did before, the same sort of graphic organizer, but applying these rate change problems to longer word problems. So kind of pulling out the information that we need from the problem and using the same sort of graphic organizers to help us answer the question as it's given to us. All right, so let's look at this example. So a study of the annual population of the red-winged blackbird in Fort Mill, South Carolina, shows the population, b of t, can be represented by the function b of t equals 750 times 1.16 to the power of t, where t represents the number of years. So that rate and the time is given up to us in terms of years. So in terms of the monthly growth rate, the population of red-winged blackbirds can be best approximated by the function, and then we have four different functions to look at here. All right, so let's take a look at this question. All right, so again, the main takeaway has been that the units for the rate need to match the units of the exponent. All right, so I'm just making a quick note of that here as a reminder. All right, so let's look first at the rate. So this rate is given to us in terms of a yearly rate, and we need to change it to a monthly rate. So here we are getting smaller. Our time frame is getting smaller. So what does 1 month then represent in terms of a year? Well, it represents 1/12 of a year. So I'm going to take that original rate that I was given, 1.16, and I'll raise it to the 1/12 power. Okay, I will need to use a calculator to do that, so I can go into Desmos, and let me clear out what I have here. So it's 1.16 raised to the power of 1 divided by 12, right? And I get this really long decimal here. I'm going to write that up to... I'll round to the nearest tenth, hundredth, thousandth, 10,000, 100,000s, but let's see what that looks like. All right, so my rate, which is now a monthly rate, is going to be 1.01245. So that's to the really fifth number after the decimal. Okay, so now let's look at our exponent. So again, for my exponent, we're going from years to months. So if I'm given 2 years, I would need to multiply that by 12 to get the number of months. So I would take my variable t and I multiply it by 12, so 12t. All right, so given that, I can rewrite my new equation. So that's b of t equals, what I started with is still 750 times 1.01245 raised to the power of 12t. So let's look at our options now. I can definitely eliminate 3 and 4. The rate doesn't match. So now if I look at options 1 and 2, option 1 doesn't have the correct exponent, so choice 2 is the correct equation. Okay, so on the Google form, you'll need to submit the correct answer choice for question 1, question 2, and question 3, and also question 4. All right, so here again is the example. You can pause the video if you need to and write that down.